Jntuh R18. mm, 1 minute. Yeah, it is about the irrigation and hydraulic structures. Now we are going to discuss about the gravity dam. uh, Gravity dam is generally a storage dam which stores the water. Here it got this name as gravity dam because of its weight. Most of the action is done because of the weight of the dam. That's why it is. And moreover, that weight of the dam offers resistance against various stresses stresses and external forces. Yeah, that's why this dam is named as a gravity dam. And this dam is durable and solid one. Durable in the sense it can last for a long time, yeah, without any failure. And the maintenance cost is also very less because the dam is durable and strong. If you want to build a gravity dam, definitely your foundation should be the strong one. Otherwise we cannot construct the gravity dam. Mostly gravity dams are constructed with masonry or concrete. Nowadays most of the dams are gravity dams only. And one of the famous gravity dam in India is Bakra dam. That's all about the introduction about of gravity dam. Now we are going to discuss some forces that are acting on a gravity dam. This is the important one. As you know, whenever you construct a dam, not only a dam, any engineering structure, definitely some forces act, like wind pressure or any gravitational pressure. Like some forces will act on any engineering structure. In the similar way, now we are going to study about the forces that are going to act on the dam. The first important force is water pressure. Yes, water pressure is the one which is generated because of the water. Of the water, this is the major and which shows the more effect, on the dam. Here you can see a picture. Yeah. mm, this is the upstream side. And this is the downstream side. Upstream side, uh, the height of the water on upstream side is capital H, whereas this is the H dash. And moreover, 1 minute. Yeah. mm, Here, uh, first thing is, let us study what is meant by the water pressure. Here you can see the triangle, right? This is the triangle which is generated because of the water pressure. First one, uh, here, this is we can say whenever a water pressure is created on the dam, it will appear like in the triangle shape. It appears like in triangle shape. And moreover, we can calculate the intensity of the water pressure as gamma w into h. Here you can see the intensity of the water pressure is more at base of the dam, but whereas the intensity is very less on the water surface, because the water surface is exposed to the atmospheric, right? It is totally exposed to the atmosphere, and then definitely the intensity of pressure will be more. But whereas here the intensity will be, sorry, here the intensity is less because it is exposed to the air, that is atmosphere. Here the intensity will be more. Why? Because the total weight of the water is acting here. That's why the intensity will be more. And here we can write intensity as gamma w into h, whereas gamma w is nothing but unit weight of water. Gamma w represents the unit weight of the water, and capital H represents the height of the water on upstream side. We can consolidate these two forces, this up one these two forces into single line, this into single line, that is nothing but half into gamma w into h square. How do you get this formula? Yes, it is nothing but the area of triangle, that is half into base into height, where base is nothing but yeah, here base is gamma w into h, height means anyhow the height of the water. And in the similar way, in the similar way you can see the on downstream side, on the downstream side half into gamma w into h dash square. Here you are replacing the capital H as h dash square. Yeah, that's it about of water pressure. Now let us move to the second important pressure, that is uplift pressure. Uplift pressure is generated by seepage of water, by seepage of water. Whenever the water seeps into the uh, into the cracks of foundation, whenever the water goes into the cracks of foundation, that water again rises and it shows effect on the base of the dam. That is not, it creates some uplift pressure over the base of the dam. It creates some uplift pressure over the base of the dam. This is the second important force. And moreover, when there is an uplift pressure, the net weight of the dam will be decreased. Yes, anyhow the the net weight of the dam will be decreased because of this uplift pressure. Here here you can see this represents the uplift pressure. Here there is no drainage gallery, here there is no drainage gallery, and this is how you can represent the uplift pressure. Here on right side you can see there is a drainage gallery. You can see a drainage gallery. Because of this drainage gallery there is some reduction, there is some reduction in uplift pressure. From this we can conclude that we can control the uplift pressure by construction of drainage galleries as well as cutoffs. By construction of drainage galleries as well as cutoffs, we can control, we can control the uplift pressure. Here itself you will get, here the diagram shows there is some reduction in uplift pressure, but here there is no reduction, there is more uplift pressure in this stress distribution diagram. And we have to learn one formula regarding this uplift pressure, that is gamma w h, gamma w h dash plus 1 by 3 into gamma w h minus gamma w h dash. Yeah, and the third one, and the third one is earthquake pressure. First one is water pressure, second one is uplift pressure, and third one is earthquake pressure. Earthquakes are common, right? As you know, there are 5 seismic zones in our country, in India, whereas fifth zone number 5, where Himalayas comes under zone number 5, that is the dangerous one. uh, we have to design the dam, we have to design the dam so that it can resist against the earthquake force. Earthquakes are nothing but they produce some seismic waves, they produce some seismic waves. Because of that waves, it may shake, it may vibrate the dam foundation, it may vibrate the dam foundation. The intensity of the failure because of this earthquake can be determined by 3 ways. If the mass of the dam is more, you can reduce the earthquake, it can have more resistance. If the mass of the dam is less, it has very less resistance against earthquake pressure. And one more thing, if the severity of the earthquake is more, then definitely it will affect the gravity dam. And one more thing, if you know the seismic coefficient, if you calculate seismic coefficient, by seismic coefficient we can determine the intensity of the earthquake. That's all about earthquake pressure. And let us move to next pressure, that is silt pressure. Silt silt or debris, both are same. The rivers gradually they carry silt and debris, and most of the silt is collected at the bottom of the reservoir, that is behind the hill. It also exerts some pressure. It means silt also produce some pressure against uh, against the dam. Here we can calculate the silt pressure by Rankin's theory. We can calculate the silt pressure by Rankin's theory. The formula is of into gamma su, gamma suffix su into h suffix square, again in bracket 1 minus sine alpha, sorry, 1 minus sine phi by 1 plus sine phi. Once again I am repeating, of into gamma su into h hs square, hs square into 1 minus sine phi by 1 plus sine phi, 1 plus, that's a formula, simple formula by Rankin's theory for the calculation of silt pressure. And next one is wave pressure. Wave pressure, uh, waves are produced due to wind. Whenever the wind flow, whenever wind move along the water surface, generally some waves are produced. Here waves they also show some impact on the dam, and the intensity of the wave pressure depends upon the height of the wave, height of the wave. Here also a small formula is there for the wave pressure, a small formula, that is h is equals to 0.032 0.032 into under root of v into f, v into f, where v indicates the wind velocity and capital F indicates fetch, FETCH. It's a simple formula, you need to just write that formula. This force acts at 3 by 8 of the HW. And the sixth one is ice pressure. Ice pressure, uh, this ice pressure is considered for the dams if the dams are located in cold countries and high altitude countries, high altitude places, where in high altitude places the temperature is very less, and it the temperature is very less, uh, and moreover uh, here the variation of temperature is also important, because if the variation of temperature is more, for suppose the variation of temperature is more, then ice rapidly contracts and expands. The ice rapidly contracts and expands. Because of this contraction and expansion, it may create some pressure on the dam. It may create some pressure on the dam. Yeah, that's all about the ice pressure. And one more, the last thing regarding ice pressure, that is the thickness of the ice. If the thickness of the ice is more, it shows more impact on the stability of the dam. And the last one is weight of the dam. Weight of the dam is also important. uh, if you want to calculate the weight of the dam, there is a simple formula, that is cross section of area into specific weight. Once again I am repeating, the weight of the dam per unit length can be calculated by multiplying cross sectional area of the dam and specific weight. Here the cross sectional area of the dam can be represented in the simple shapes. Simple shapes are nothing but triangle and rectangle in our convenient way. Yeah, that's all about all these pressures, all these forces and pressures act on the gravity dam.